All right, and welcome back. So today we are going to be talking about special products of binomials. Now, before we begin, if the things we go over today do not really click, that's completely okay. Today is all about figuring out shortcuts to get to our answer. We can always use the foiling method or just the method that we use to multiply binomials together if what we are doing doesn't necessarily click. But with that, if we can figure out these shortcuts, is going to make our mathematical work a lot more efficient. So with that in mind, let's begin. Before we really start talking about what's on your guided notes, let's recall what exponents represent. If we have x squared, that's really the quote unquote shorthand of x times x. We're saying whatever that value of x is, it's getting repeated twice through multiplication, since exponents represent repeated multiplication. If we had y to the third power, well, y to the third would be y times y times y. We're saying that base of y is multiplied by itself 3 times. So we're going to be using this idea to help us with these special products of binomials. Taking this idea, if we have a binomial squared, then we do not distribute the exponent. This idea here is a very common error for students, especially starting out. So if we can be aware of this error, it's going to help us not make it. And here's what I mean. Instead of distributing the exponent, we're going to multiply the binomial by itself to the number of the exponent on the outside of the parentheses. That's a lot of jargon, and that's okay. We're going to go through an example to show what we mean. Let's say we have 2x plus 3. That binomial is inside of a set of parentheses, and everything in there is getting squared. We do not distribute the 2. We don't send the 2 to 2x and 3. So it is not 2x squared plus 3 squared. Rather, we're going to go back to where we started up here. We know that x squared is x times x. Y to the third, or y cubed, is y times y times y. So what we do is we take what's inside the set of parentheses, that 2x plus 3, and we multiply it together twice. So it turns out it's 2x plus 3 times 2x plus 3, because exponents represent repeated multiplication. So it's telling us that 2x plus 3 will be multiplied to itself twice. This again is a common error that students make. Some students like to distribute the exponent of the 2, and we cannot do that. That is not mathematically proper. We have to, though, understand that we have to write our binomial twice if it's getting squared. If it were to be getting cubed, or to the third power, we would write 2x plus 3 times 2x plus 3 times 2x plus 3. Whatever the exponent is on the outside of a set of parentheses, we multiply what's inside that many times. Awesome. Now, with that in mind, let's now start to approach these special products of our binomial. So please have out your guided notes. We're going to be talking about what's called a perfect square trinomial. That's a trinomial that the result is when we square a binomial. Just like we were talking about before, that 2x plus 3 squared, that's going to have a special answer. So if we have a plus b, whatever a is, whatever b is, and that's all squared, our answer actually turns out to be a squared plus 2ab plus b squared. And again, this is just a shortcut here. Oh no, I'm so sorry. Close your eyes as I try to navigate this. I got it. Okay. So we're going to square a, which is that first term. So in the previous example, it will be 2x. We're going to square b, which is that second term. Again, in the previous example was 3. And we're going to add the product of 2a and b. So we're going to multiply those two terms together and then double it. That's going to be a perfect square trinomial. We have a plus b. Now we also have a special scenario where we have a minus b, and it's very, very similar. It's going to end up being a squared minus 2ab plus b squared. And again, we're going to square a. We're going to square b. Now notice how we get plus b squared. Because if we have a negative here, this is saying negative b. So a negative times a negative turns into a positive, which is why we get plus b squared. And we're going to subtract 2ab. So we multiply a and b, and then multiply it by 2. Turns out it's going to be a negative. Awesome. So with this in mind, this probably looks a bit daunting, and that's okay. This is shorthand. These are shortcuts. We're going to go through a couple of examples together, though. On the left-hand side of your guide and notes, we're going to go through the quantity x plus 4 squared. Remember, we do not distribute the exponent. Rather, we're going to write out x plus 4 times x plus 4 if we want to use a foiling method. But we can use this idea of special products of these binomials. We're going to identify what our a and our b terms are. Our a is going to be x. Our b is going to be 4. So we're going to use this to help us figure out the answer. So we're going to do x squared, because that's a squared, plus 2 times a times b. A is our x, b is our 4, plus b squared, and b is 4, so 4 squared. Now we can simplify. 2 times x times 4 is 8x. So therefore, our answer is x squared plus 8x plus 16. Now, if you did not use this method and you rather wrote out x plus 4 times x plus 4, you're going to end up with the same answer. X times x is x squared. X times 4 is 4x. 4 times x is 4x. And 4 times 4 is 16. I can combine the middle terms, 4x and 4x, and we get x squared plus 8x plus 16. Notice it's the same answer. But knowing that this is a special product is going to be a little bit more efficient for us. That's all we are trying to talk today about, is being a little bit more efficient if we can. All right, on the right-hand side of your guided notes, we're now going to multiply 4x minus 3 squared. So we first want to identify what is our a term, what is our b term. A is the first, which is 4x. B is going to be 3. We're going to square a, so that's 4x squared, so that's 4x times 4x. 4 times 4 is 16. X times x is x squared. We're going to square the b term, and our b term is 3, so we get 9. And then we're going to subtract 2 times a times b. So 2 times 4x times 3. Again, a is 4x, b is 3. So we multiply them together, and we receive 16x squared minus 24x plus 9. Now again, if you use the foiling method, we should end up with the exact same answer. So we're going to have 4x minus 3 times 4x minus 3. And when we start to FOIL and start to distribute, we get 16x squared. 4x times negative 3 is negative 12x. Negative 3 times positive 4x is again negative 12x. And negative 3 times negative 3 is positive 9. We can combine those like terms in the center. So we get 16x squared minus 24x plus 9, which again is the same answer as we got. So we're talking about being a little bit more efficient. If by the end of today and we really start to practice with it, it doesn't click, it's okay, because we are going to be able to still use the foiling method. Awesome. Great job so far. With this, please work on problems 1 through 9 on the guided notes and resume when you're ready to move on. All right, so if you listen to my voice, that means you should be on the back side of your guided notes. So here we go. When you multiply certain types of binomials, the middle term will end up being 0. If we are going to be multiplying a plus b and a minus b, whatever way we do it, we're going to see that the middle terms will cancel out. So you can do whichever method you want to. Again, in the guide notes, we do it a little bit more step by step, and it may seem a bit daunting and a bit confusing. That's okay. We're going to go through another method on the right-hand side. So we're going to distribute the A, and we're going to distribute the B. When we do that, you're going to see that we have negative AB plus AB. Well, negative 5 plus 5 is 0. Negative 1 plus 1 is 0. Negative 10 plus 10 is 0. Negative AB plus AB is also going to end up being 0, in which we end up with A squared minus B squared. Now, if you were to FOIL this, you would have been doing the exact same process, but it might look a little bit different. A times A is A squared. A times negative B is negative AB. B times A again is positive AB. B times negative B is negative B squared. So we end up again canceling out right here. Negative AB plus AB goes bye-bye, and we're left with A squared minus B squared. So again, this is another shortcut for us. This is what we call the difference of squares. And we call it the difference of squares because we end up with A squared, that's technically a square, minus B squared, that's also a square. And it's the difference of squares because we're dealing with subtraction. And the answer to a subtraction problem is the difference. So A squared minus B squared turns into a difference of squares. This all started when we had A plus B times A minus B. Notice how we have the same first term, same second term, except one has a positive and one is negative. Awesome. This is exactly what happened when we have that difference of perfect squares. It's going to be A squared, or the square of A, minus the square of B. Beautiful. Let's go through a couple of examples. We're going to use this method to help us out. Let's say on the left-hand side of our guided notes, we want to multiply x plus 4 and x minus 4. One of the first things that I notice when it comes to this problem is that I have the same first term, is x, technically the same second digit, which is 4, but one of the 4's is positive and one of the 4's is negative. This is going to help us out with a difference of squares. So we're going to identify our a and our b. Our a is that first term, which is x. B is the second term, which is 4. And we're going to do x squared minus 4 squared, which turns into x squared minus 16. That's it. Again, if we were to do it elongated, we did it the long route. Again, I changed my color. I'm so sorry, but it's gold. Go Vikings. So if we have x plus 4 times x minus 4, we start to FOIL. X times x is x squared. X minus times negative 4, pardon me, is minus 4x. 4 times x is plus 4x. 4 times negative 4 is negative 16. You're going to see that negative 4x and positive 4x, those cancel out. And again, we are just left with x squared minus 16, which is the same result that we got before. Awesome. Awesome. On the right-hand side of your guided notes, let's multiply 7 plus 8x and 7 minus 8x. Again, this is going to be a difference of squares because we have the same a term, it's 7. Technically the same b term of 8x. One of them is positive and one of them is negative. So we can use this method to identify our a, which is 7, that first part of the term. And then we're going to have 8x is our b, the second term. And we're going to do 7 squared minus 8x squared. 7 squared is 49. 8x squared is saying 8 squared, x squared. We get 49 minus 64x squared. And that is how we do difference of squares. And this is the end of chapter 6 and the end of dealing with binomials for right now in this chapter. So with this in mind, please work on problems 10 through 18 on the guided notes. Y'all are doing a fantastic job. Keep making yourself proud. I know I'm proud of you, and you should be proud of yourself. Please let me know if you have any questions, and I'll talk to you soon.